Hello students, today we are going to discuss an interesting concept from number system, that is operations on real numbers. In our previous classes we discussed about what are the rational numbers, what are the irrational numbers, and what are the real numbers, how to construct a square root spiral, how to locate real numbers on a number line. These are the concepts we discussed in our earlier classes. Today, how to operate the real numbers, how to operate in the sense, in mathematics we have four fundamental operations: addition, subtraction, multiplication and division. We know how to add the numbers, how to subtract, how to multiply and how to divide. Today we are going to discuss about how to apply the operations on real numbers, means real numbers. As we know that real numbers means the combination of rationals and irrationals. Now, when we add rationals alone, or when we apply these four fundamental operations on rational numbers, if you apply those fundamental operations on irrational numbers, and the combination, if you apply the operations between rationals and irrationals, what is going to happen? Means that when we add rational numbers alone, what we have? When we subtract rational numbers, when we multiply rational numbers, when we divide rational numbers, what we have? When we add irrational numbers, when we subtract irrational numbers, when we multiply irrational numbers, when we divide irrational numbers, what we have? When we add rationals and irrationals, when we subtract rationals and irrationals, when we multiply rational numbers and irrational numbers, when we divide rational numbers and irrational numbers, what we have? That we are going to learn in this class. So that is the concept we have: operations on real numbers. Operations on real numbers. Now let us see here, by observing the concepts, means by solving some examples, we can have some information. By adding or by subtracting, by multiplying, by observing a few examples, we can come for one conclusion. Let us see what are the examples we are going to discuss, and through those examples what we are going to understand the concept we discuss. Number 12. What is there here? Check whether 7 root 5, 7 by root 5, root 2 plus 21, 5 minus 2, or irrational numbers, or not. Now this is the problem we are going to discuss here. How to discuss it and what to discuss it. How to discuss and what to discuss. When we observe here, the question is like this: check whether 7 into root 5, 7 by root 5, root 2 plus 21, 5 minus 2 are irrational numbers or not. As we know that, what we know? We know that root 2, root 3, root 5, root 6, root 7, root 8 and so on are irrational numbers. That we know very well. And we have constructed these irrational numbers on a number line also. As we know that the square root of a whole number is not a whole number, then such numbers are nothing but called irrational number. We have seen the definitions and we know that these are the irrational numbers. And we have two special irrational numbers. What are they? Pi and e. Pi and e. These are also called transcendental irrational numbers. These are called transcendental irrational numbers. These are two different types of irrational numbers. Pi, we know that pi in circle structure, when we use to find the area of a circle or perimeter of a circle, we use to use the value pi. Even in physics also we use the value of pi. Here e is nothing but exponential. So here pi and e are nothing but called transcendental irrational numbers. So root 2, root 3, root 5, root 6, root 7, root 8 are alone an irrational numbers. Pi and e are also an irrational numbers. Now what we have here, 7 into root 5. As we know that 7 is a rational number and root 5 is an irrational number. Now the combination of 7 into root 5 means what we are discussing here? The product of a rational and an irrational. 7 by root 5. 7 is a rational number, root 5 is an irrational number. So again here, the combination we have rational and irrational. Root 2 is an irrational number, 21 is a rational number. We are adding. Pi is an irrational number, 2 is a rational number. Again the combination. Means here we are performing 4 operations. What are they? Addition, subtraction, multiplication and division. The 4 fundamental operations we are performing between a rational and an irrational number. Hope you understood the problem. What we are going to observe here means we are performing 4 fundamental operations. What are they? Addition, subtraction, multiplication and division. Between what? Between a rational number and an irrational number. So when we perform these 4 fundamental operations between a rational and an irrational, what is going to happen? That we are observing here. As we know that, what we know? We know that root 2 value is approximately 1.414 and so on. Root 5 value is nothing but 2.236 and so on. Pi value is nothing but 1.314 and so on. These are the approximated values. Root 2 1.414. We know the procedure. We have a procedure how to find the square root of irrational numbers. Means we can find square root of 2, we can find square root of 3, we can find square root of 5. Like that, all those square roots we can find. We have a procedure how to find it. Now, in that way, the value of root 2 is approximately we consider as 1.414. But it is actually an irrational. Irrational means we know that which is a non-terminating and non-recurring decimal. So it never ends. So that 1.414 and so on, which is a non-terminating and non-recurring decimal. Similarly, root 5, 2.236 and so on. It is also non-terminating non-recurring decimal, which is called an irrational number. Pi, just now I told you, pi and u are called transcendental irrational numbers. The value of pi is 1.314 and so on. It is another irrational number. So, when we multiply rational and irrational, what we are going to have? We have simply look at here. 7 into root 5 is equal to 7 into root 5, 2.236 and so on. When we multiply this value, what we have? Let us observe. 7 6 are 42, 7 3 are 21 plus 4, 25, 7 2s are 14 plus 2, 16, 7 2s are 14 plus 1, 15. So 15.652 and so on. Means it is an irrational number. 7 is a rational number. When we multiply a rational and an irrational, the value what we are getting 15.652 and so on. It is an approximate value. Of course, if it is an approximate value, look at the decimals. Here the decimals are not ending, means non-terminating decimals, and the digits are also not repeating, means non-recurring decimal. So finally, it is a non-terminating and non-recurring decimal. So when it is a non-terminating or non-recurring decimal, we know that is an irrational number. Is an irrational number. Next, coming to the another 7 by root 5. 7 by root 5. Here 7 by root 5. Root 5 is in denominator, means irrational number we have in its place, denominator place. Denominator, the value should not be an irrational number. Whenever you have an irrational number in the place of denominator, you need to rationalize it. We have a special concept, rationalizing, that we discussed. So what to do means 7 by root 5 into root 5 by root 5 means here whatever the denominator I have, with the same denominator I am multiplying the numerator and also multiplying the denominator, means just we are balancing. Let us multiply. What we have? 7 into root 5 by root 5 into root 5 is nothing but 5. Root 5 into root 5 is nothing but 5. Now we know that 7 root 5 value is how much here we know. What is that? 15.652 and so on by 5. When we simplify this, 5 3s are 5 1s are 5 3s are 5 0s are approximately 5 4s are and so on. It will come and so on. So here also 1 3 0 4 and so on means it is a non-terminating and non-recurring decimal. It is also an irrational number. It is also an irrational number. Now first is over, second is over. Now we discuss about third one. What is the third one? Root 2 plus 21. What is the root 2 value? 1.414 and so on. So 1.414 and so on plus 20. By adding this we have 22.414 and so on. Again, if you observe it, it is also non-terminating and also non-recurring decimal. So finally, which is called an irrational number, is an irrational number. And the last one, 5 minus 2. 5 minus 2. So 5 minus 2. The value of pi 3.14, 1.31. Pi value is 3.14 and so on. So 3.14 and so on minus 2. That is nothing but we have 1.14 and so on is also an irrational number, is also an irrational number because pi, the value of pi is approximately 3.143 and so on will come minus 2. While subtracting, we have 1.14 and so on. It is also a non-terminating, non-recurring decimal. Finally, we can call it as an irrational number. Now, what we are getting an information by observing these problems means we are performing 4 fundamental operations between a rational and irrationals. So when we perform the fundamental operation between a rational and an irrational, our final answers are also an irrational. If you add, if you multiply, our result is irrational number. If you divide, our result is an irrational number. If you add, irrational number. If you subtract, irrational number. Any operation you can perform between a rational and an irrational, our final answer is always an irrational number. That we are observing from this example. So, sum or difference or multiplication or division between any rational and an irrational, our answer is always an irrational number. That we have to keep it in our mind. Here we have example number 13. Add 2 into root 2 plus 5 into root 3 and root 2 minus 3 into root 3. So, before discussing this problem, I need to explain a few concepts to you. What are they? As we know that irrational numbers are also called surds. That's why irrational numbers are denoted with capital S. Irrational numbers are also called surds. In this, we have the concepts of like surds and also unlike surds. Like surds and unlike surds. Like, unlike. By just listening these words, you might have got another idea of the like fractions, unlike fractions. Where the denominators are same, they are nothing but called like fractions. When we have like fractions, we can add and subtract very easily. Where the denominators are different, they are nothing but called unlike fractions. So to add unlike fractions, we need to apply LCM concept. Otherwise, unlike fraction should convert into like fraction. Then we can add and subtract. That we know very well. The similar concept here we have like surds and unlike surds. Now, what are the like surds and what are the unlike surds? Let me explain. Why, sir? Why we need to learn like surds and unlike surds in the sense? Without knowing the likes and unlike surds, you can't add and subtract. You can't add and subtract. While performing the addition or subtraction between irrationals, definitely you have to know what are the like sums and what are the unlike sums. Now let me explain. For example, here I have a few examples. Root 2 minus 5 root 2, 7 root 2, 3 root 2, 5 by 5 root 2 by 3, etc. When we observe here, root 2 is an irrational number, minus 5 root 2 is also an irrational number, 7 root 2 is also an irrational number, 3 root 2, 5 root 2 by 3, all these are nothing but irrational numbers that we know. Now, in all these irrational numbers, what is the common factor we have? What is the common factor we have? Root 2, root 2, root 2, root 2 and root 2. Everywhere the common factor means the irrational part, we have root 2. That's why these irrationals are nothing but called, or these surds are nothing but called like surds. So, root 2 minus 5 root 2, 7 root 2, 3 root 2, 5 root 2 by 3, etc. we have. In all these irrationals, we have a common value is that root 2, that is irrational part. Everywhere the irrational part is common. So that these irrationals or these surds are nothing but called like surds. These surds we can add and subtract very easily. These surds we can add and subtract very easily. How? For example, 5 root 2 plus 3 root 2 you have. Here I have the irrational part root 2. Here I have the irrational part is root 2. So both are nothing but like surds. Directly I can add. What to be added? Coefficients has to be added. Coefficients. Here root 2 coefficient is what? 5. Here root 2 coefficient is 3. Coefficient means 5 plus 3 root 2. So 5 plus 3, 8 root 2. That is the way we need to add. For example, 5 root 2 minus 3 root 2. Here also both are like surds. Directly we can subtract the coefficients. Means 5 minus 3 root 2, which is nothing but 2 root 2. So like surds can be added and can be subtracted directly. Just adding of the coefficients and subtracting of the coefficients. This is our like surds. Unlike surds. Now, the quite opposite to the like surds are nothing but called unlike surds. Like surds means where we have irrational parts are same. Unlike means where irrational parts are different. For example, 5 root 2, 7 root 3, minus 5 root 5, 3 root 7, root 8, etc. Or here you can write root 11, etc. Now, if you observe these surds, here the irrational part is root 2, here root 3, here root 5, here root 7, here root 11. So, here all are individually irrational numbers and irrational parts are also different. That's why these surds are nothing but called unlike surds. These surds we can't add, means we can't simplify. For example, 5 root 2 plus 7 root 3. When this is the question is given add, so we can't simplify. The answer is itself. Because root 2 and root 3 are unlike surds, we can't add. When they are like surds, we can add the coefficients. Here root 2 and root 3, these are two different irrational numbers and these two are unlike surds. We can't add the coefficients, means we can't simplify. What is the value of 5 root 2 plus 7 root 3 means the value is itself. So, like and unlike search, we have to know it very carefully. Now, using this concept, let us come for our example number 13. How to add? They ask you to add means 2 root 2 plus 5 root 3 plus root 2 minus 3. First, we need to observe that is there any like search? Is there any like search? First, we need to identify. Here I have the irrational part is root 2, and here also I have the irrational part is root 2. Means these two are nothing but like search. I can add it. Means 2 root 2 plus root 2. I can add. Plus here I have root 3 and here also I have root 3. These two are again like search. I can subtract. Means 5 root 3 minus 3. Now let us simplify. 2 root 2. Here root 2 before what is the coefficient we have? 1. So 2 plus 1. 3 root 2 plus 5 minus 3. 2 root 3. This is our final answer. We can't simplify more than this. Because here root 2 and root 3, two different search, they are nothing but called unlike search. We can't simplify more than this. So, this is the value we have and this is the value we have. These two we have to add. While adding the search, you need to observe that whether you have any like search or not. When you are able to identify the like search, simply let us add it and you can subtract it. This is about example number 13. Now here we have example number 14 and example number 15. Example number 14 is nothing but multiply 6 root 5 by 2 root 6 root 5 is an irrational number. 2 root 5 is also an irrational number. So these two irrational numbers, when we multiply, what happens? And moreover, you can observe here 6 root 5, 2 root 5. Both are mixtures, like search. So here we are multiplying the like search. When we multiply the like search, what we are getting? 6 root 5 into 2 root 5. While multiplying, we should multiply the rational numbers. We should multiply the irrational numbers. Here 6 is a coefficient and is also a rational number. 2 is a coefficient and also a rational number. First, we should multiply the coefficients, or we should multiply the rational numbers, then we should multiply the irrational numbers. So 6 into 2 into root 5 into root 5. 6 2s are 12. Root 5 into 5 is nothing but 5. How it is? As we know that x into x is nothing but what? X square. So root 5 into root 5 is nothing but what? Root 5 whole square, and square can get cancelled. We have the value 5. In that way, in this way, root 5 into root 5 is nothing but 5. 12 5 is nothing but what? 60. What is 60 here? Is it a rational number or an irrational number? Is a rational number. So, earlier in example number 12, the product of rational and an irrational is nothing but irrational. Now here, the product of an irrational and also an irrational, we have a rational number. See how funny it is. Product of rational and irrational is irrational, but product of two irrational. Which kind of irrationals these are? Like surds. The product of like surds gives us a rational number. This is about example number 14. Now let us come for example number 15. What is there? Divide 8 root 15 by 2 root 3. 8 root 15, which is a irrational number. 2 root 3 is also an irrational number. These two irrational numbers we are going to divide. Let us see what will happen by dividing these two. 8 root 15 divided by 2 root 3. That can be written as 8 root 15 by 2 root 3. Root 15 I can write as root 5 into root 3 by 2 root 3. We have a square root properties. In class 8, we have learnt squares and square roots. We have a square root properties. What are the square root properties? Square root of a into b is nothing but square root of a into square root of b. Using this concept, root 15 I can write as root 5 into 3. Finally, I can write as root 5 into root 3. So we know that concept, square roots concept. Using that square root concept, root 15 we are going to write as root 5 into root 3. Now, here the root 3 and root 3 can get cancelled. 2 ones are 2 4s. Finally, numerator I have 4 root 5 and denominator I have the value 1. Finally, I have 4 root 5 is an irrational number. So, here 8 root 15 is an irrational number. 2 root 3 is also an irrational number. By dividing these two irrational numbers, again we have an irrational number. Here, product of like surds gives us a rational number. Division of two unlike surds, we have a irrational number. This is the operation between like surds. This is the operation between unlike surds. When we perform operation between like surds, we have a rational number. When we perform division operation between unlike surds, you have again an irrational number. So these are the examples about example number 14 and example number 15. Here we have a few observations based on our previous examples. Observation number 1. The sum or difference of a rational number and an irrational number is irrational. That we have seen our example number 2. Whenever we add a rational and an irrational is always an irrational number. Next, the product or quotient. Quotient means division. When we perform a product operation or division operation between a non-zero rational number with an irrational number is also irrational number. These 2 points we can get from example number 12. In example number 12, we have performed 4 operations, means addition, subtraction, multiplication, division between the rational and an irrational number. In that case, we got all our answers are as an irrational numbers. That we are saying here. While sum or difference or product or quotient between a rational number and an irrational number, our answers are always an irrational numbers. Next, if we add, subtract, multiply, divide 2 irrational numbers, the result may be rational or irrational. The result may be rational or irrational numbers. So, when we add or when we subtract or when we multiply or when we divide two irrational number, so your result may be a rational number or maybe an irrational. We can't say which one we get, but in first two cases, no doubt at all, they are 100% irrational. But in third one, may or may not. As I told you, example number 14. When we have like such when we multiply, we have a rational number. Unlike such when we divide, we have an irrational number. So, sometimes you may have rational number, sometimes you may have irrational number. Now here, the last one we have the definition of irrational number, is such definition. Let a greater than 0. A greater than 0 is, it must be a positive number. A greater than 0 be a real number and n be a positive integer, then nth root to a we read it as nth root a. We have to read it as nth root to a is equal to b. Nth root a is equal to b. Similarly, this can be converted as b power n is equal to a. Here this nth root goes that side, becomes a power of b, means b power n is equal to a, and b is also greater than 0. This is about such definition. A must be a positive real number, n be a positive integer, then nth root a is equal to b if b power n is equal to a. Nth root comes this side, it becomes power n, or power n goes that side, it became nth root. In this, a is nothing but called radicand, means under nth root, whatever the value we have, that is nothing but called radicand, and nth root is nothing but called radical sign. Radical sign. So this is about operations on real numbers, the introduction. Based on this concept, we have a few formulae and also exercise problems that we see in our next class. Hari Om.